How's it going, ladies and gentlemen? Mr. Johnny here again, taking a look at pH. All right, so in this video, hopefully you walk away knowing what is it. What is pH? Why is 7 neutral? And also, how different is the pH of 4 compared to the pH of 5? So let's get started with, well, what is pH? And it's a measure of H+. Remember, an acid gives off an H+. So pH is measuring how much H+ is there. Specifically the molarity. So what's the molarity of the H plus? Now the formula for pH is the negative log of the concentration of H plus. So that's just the math. How do you calculate it? If you knew H plus, you plug it into this equation right there. If we take a look at this scale down here, you can see that the H3O plus, remember, is hydronium, which is from the H plus that dissolves from the acid. So as we become lower pH, the more acidic it becomes. The more H3O plus we have, the less OH minus we have. And the opposite is true. If we get more basic, if the pH goes higher and higher, the number of H plus goes down, but the OH minus goes up. Because remember, that's more basic. Bases give off OH minus. So why is 7 neutral? Right? Why not 0? Why is 7 got to be the neutral stuff? Well, if we take a look at water, water is a universal solvent for like all living things. It all comes down to water. Well, what does water do? Well, we know it's H2O, but it actually is in equilibrium. It doesn't always stay together. Sometimes it breaks up into an H plus and an OH minus. If you take a look, there goes the H plus, and it breaks apart. So this dissociation of water, the breaking apart of the H plus from the OH minus, happens normally. And the question is, all right, well, if water is doing that, how much H plus do we normally have at room temperature for water? And it turns out that the concentration of H plus is 10 to the minus 7 molar. So if we know that H plus equals OH minus, right? Because every time you break one water molecule, you get one OH minus, but you also get one H plus. So they're equal to each other. That's neutral. And if we measured it for water, all right, well, water, we get 10 to the minus 7 molar for the H plus concentration at room temperature for pure water. So we plug that into our negative log of H plus equation, and you just get pH of 7. So that's why 7 is neutral. It's what water does normally. All right, so question would be, well, how does the pH of 4 compare to the pH of 5? All right, how different are they? Well, you got to remember that it comes down to this equation, and that should be lowercase p, capital H. pH equals negative log of H plus, which, if you guys remember logs with base 10, so if I had log base 10 equals x, well, you can get rid of the log, and you'll get, 1 equals 10 to the x, right? Then x would have to equal 0, right? So we're just rearranging this log equation to solve for, instead of pH, solve it for H plus. So we can go, all right, well, let me rearrange it. So we get 10 to the negative pH equals concentration of H plus. All right, well, what's going to happen if we change the pH from 4 to 5? How big of a difference is that? Well, remember, it's 10 to the. So every time you change it, you're changing it a 10 times concentration. So if you go from 4 to 5, or vice versa, that's a 10 times difference in H plus concentration, right? So 4 being more acidic has 10 times more H plus than pH of 5. All right, so if we're going 3 to 4, well, 3 is more acidic. How much more acidic is it? Well, it has 10 times more H plus, because it's a change in pH of 1. Every time you change, it's 10 times. Now, 2 compared to 4. All right, well, let's think about this. If we were going from 4 to 3, that would be a 10 times change. And then 3 to 2 would be another 10 times change. All right, so 10 times and then 10 times that gives you 100 times more H plus. Now, I know easy mistake is to say 20 or 2. It's not. Remember, every change in 1 pH is a change in 10 times the H plus concentration. So if we change 2, well, then that's 10 times 10, that's 100, or 1 with 2 zeros. Now, if we're going from 14, which is pretty basic, to 9, which is not as basic, well, that's a difference in 5 pH, right? Change in pH of 5. All right, well, that's every time you go 1, it's 10 times. So it's really 10 times, 10 times, 10 times, 10 times, and then 10 times one more time. And that's going to give you a 1 with 5 zeros. See if I can count. That's 4 and 5. There you go. So pH 9 is 100,000 times more acidic than a pH 14. All right. So remember, every time you change pH of 1, it's 10 times difference. And that's it. Indicators, that's a whole different video. So I will see you in class. Peace out, Cub Scouts.